All right, everyone, thank you for joining. Last session for the day here. We'll be covering a few key issues today in this last session here around how to best make the best use of AI, thinking about potential consequences, the potential risks, really wanting to understand, identify them, and looking at different ways that we can sort of proactively counter them. My name is Michael Tjalve. I work on a team called Tech for Social Impact within Microsoft Philanthropies. We work on technology for the nonprofit and humanitarian sector, work with nonprofits all around the world. I focus specifically on AI. I also teach AI in the humanitarian sector at the University of Washington, get to work with a younger generation there. And so today I'll give you a few examples of some of the work we have done in partnership with some of these organizations, and then look at some of the principles that we sort of make sure to teach and raise awareness around with these organizations to make sure as they implement AI capabilities that they have good understanding of potential risks so that you can design accordingly. So in the tech sector, there's a long history of philanthropic initiatives. We bring a set of expertise around what the technology can do and what we can build on top of what is already there, but through the partnerships with these nonprofit organizations that we really learn what's important to them. It's a question of sort of connecting the dots between what the technology can do and what the true needs are. That's sort of really where the magic happens. We may have provided technology that feels like it's the best thing since sliced bread, but if it doesn't actually address a real challenge or a real need for these organizations, it's not worthwhile exploring even further. So the nonprofit sector in particular has not really been one that sort of jumped to the latest cutting edge technology for a number of very good reasons. So one is just awareness, understanding what the technology can do, what's real. One of the key limitations is around cost. What may seem as sort of investing in unproven technology as opposed to continuing with existing technologies and solutions they're building that may be suboptimal, but is working mostly. That is often sort of a hard discussion to have. So we make sure that we sort of build trust into the scheme, into the conversation here, into the partnership, so that they feel comfortable using the technology and work with us, particularly because many of these organizations are working with at-risk populations. And so it really is key here that we take into consideration all the different ways that AI can be used, as well as the ways that you may end up seeing unexpected consequences, and then you can implement mitigation strategies for that. So these are some of the key challenges that we are working on with these organizations. And when we talk about humanitarian crises, in broad terms, we talk about the humanitarian activities around promoting human welfare, saving lives, relieving suffering, and maintaining human dignity. And then if you look around the world today, there's no shortage of challenges. Living with historic health and economic crises, political unrest, and of course the devastating effects of climate change. And so this map shows, as an example, the levels and risk of hunger around the world. That's just one metric. And of course, there's a lot to take in. However, that also means that there are fantastic opportunities for real-world impact, societal scale impact in how we build and how we use technology. And so for me personally, I find that incredibly fulfilling, humbling, and inspiring to be able to play even just a small part in helping these organizations achieving their mission and scaling up their impact. So I'll give you a few specific examples of projects we have built with these organizations. If you follow the timeline here, you can see early 2020. I'm sure you're familiar with a lot of big changes happening there. This graph, of course, around the time where quarantine started in many places around the world due to COVID. And of course, this could show a number of different things. They could, for example, show an increase in searches of the word mask, or it could show an increase in the number of sick days across the general population. However, what it does show is the number of cases of domestic violence. And so you can see a significant spike around the time where the lockdown started. And it's an important reminder that not everybody can find safety at home. And so this data is from Peru, but we have seen similar patterns all around the world. So we worked with a couple of nonprofits, Seguro Project and Paz para las Mujeres, on building a conversational AI solution, chatbot-based solution for people who are victims or at risk of being victims of gender violence, specifically in Puerto Rico. At the time, the governor of Puerto Rico declared a state of emergency due to gender violence, and it is now a solution that's out there and getting a lot of activity, got a lot of usage, and then, of course, providing a lot of value. And so really taking sort of the broader general purpose AI capabilities, understanding the specific use case with the local expertise of those nonprofits, is absolutely critical in order to develop something that addresses the real challenge, a real need, and has real-world impact. Here's another example. This is more recent from last year, where we've worked with a nonprofit called Education Development Center. They have language learning programs throughout the world. Programs, they've been seeing some programs in indigenous communities where the younger generation often is unable to speak the language, the local language, and have a hard time communicating with the older generation. And so this is sort of a classic case of endangered languages. And so what we built here was an AI-based solution that can help preserve and revitalize these languages. It offers oral language skills, spoken language assessment in the local language, and sort of stimulates the usage of that language. Here are a few other use cases, just sort of a high-level overview, some of the common use cases we see with nonprofits. The top left here, you see it is again, a chatbot we built with Norwegian Refugee Council, University College Dublin, as well as co-designing with young refugees coming out of the Syria crisis to help them get access to online learning material. And the chatbot in Arabic asks questions about sort of what they're interested in, what their level of expertise in certain areas are, and then it finds appropriate online free material for them. And some of the others here, very common use cases, content generation, for example, to grant proposals, job descriptions, summarizations. For those of you who were in my session yesterday, this is a very common use case when you have too much data, too much content to go through manually, getting a summarization for that. A lot of nonprofits have educational content, working with, for example, a healthcare nonprofit that creates educational videos. Most of those start in English, but they're interested in that. Then also offering those in many different languages. You can do that, creating a custom text-to-speech, custom voice, and then translate that into other languages so that the person there can speak different languages, and you can do lip sync alignment to that as well to make it look more natural. The other example, actually, I'll call out, is questions on your data, because you may have access to a whole lot of data. Being able to put that data in front of the model allows you then to start to get insight from the data to ask natural language questions on that. A more recent one as well, we've been working on last year with Goodwill. For those of you who don't know Goodwill, it's a nonprofit in the US that does a lot of local community work. They have a lot of programs to help local communities. And one of the ways they're able to do that, those programs include like career training, career guidance, career matching. And so they're able to fund most of those programs through their donation model. And so they get a lot of donations. They get millions of items donated. You drive up, you drop off your donations. And then that goes into a process where it gets transferred to both their brick and mortar shops as well as their online retail store. And it's a fairly slow and manual process. And so we were thinking about, can AI play a role here? Can we make this more efficient to sort of speed up the process and be able to process more of these donations, get them online to the retail store, so where they can sell items, and then that can fund their programs and scale more to more impact in the local community. And so we built a solution. I have it on my phone. I can show you here after. I have a little illustration of it here. But essentially, you take a photo of the donated item, in this case, a shirt. You take a photo of the item itself, and then you take a photo of the different labels that may be there, and then you hand that off to the generative AI model, which generates for you automatically the listing that can go online on Shop Goodwill. So what this does is we train a custom model on the clothing items. So it doesn't have all the categories available online, clothing items so far. So custom computer vision to recognize the different subcategories, for example, a dress or women's shirt or something like that. And then from the images, so from the labels, we do use OCR to extract the text. And all that information we hand over to the generative AI model that, as you can see here, generates the description, identifies the subcategory. It even recommends a price. And then the lister can look at that, generate a content, edit if needed. If not, it goes straight into to the online store and is available there. So very different ways of using AI, very powerful applications of generative AI. And so I wanted to take a look at, just very briefly, how we got here. And including very high level how AI works, how it makes decisions, and how it makes mistakes. I know many of you have a good sense of this already, but we'll come back to this because it helps in terms of understanding, as you integrate AI in your solutions, in your work, what are some of the pitfalls, what are the things to look out for? And so, no surprise, nothing new here, suite of technologies that simulate human abilities like seeing, perceiving, understanding, reasoning, as well as speaking and hearing. And there are many different ways of illustrating the different branches of AI. This is sort of my attempt. But essentially, these are sort of the key areas that we focus on, that we leverage in terms of AI. Of course, you can combine these. Let's say you build a chatbot. You can choose to use speech in front and after. So this is now a spoken language access chatbot. And you can sort of use many of these to build out a more sophisticated solution, more sophisticated capability. And we have seen major breakthroughs over the past decade plus. Actually sort of really kicked off by deep learning a little over a decade ago here. And have reached human parity in a number of these different benchmarks, including machine translation, speech recognition, natural language understanding. It is important to understand, though, that human parity is just one metric. It's typically on one specific benchmark data sets that's publicly available. It doesn't mean it's always at human parity. Sometimes it's even above, but it's a good metric. It gives a good indication of sort of how we improved over time. And no surprise here in November 2022 with the ChatGPT coming out. And since then, generative AI has really been dominating the landscape. So the question is, why are we having this conversation now? And so it really comes down to these three components. So the availability of significant amount of data that just keeps expanding, keeps growing. Cloud computing, and particularly for these large language models, custom-built infrastructure to train and host and run these very large models. And then, of course, just more efficient algorithms that keep improving. And so these models, they simulate how we learn, how we think as humans. And so if you look at, this is sort of the traditional structure of processing data in several layers with decreasing layer of abstraction, which is why it's called deep learning, with all these different layers, where the output of one layer becomes the input to the next, et cetera, et cetera. And so for each layer, the model hypothesizes something more concrete. And so if you see example here, we input some pixels here, and out comes, after some processing for each layer, let's say maybe it's a cup. You start by saying it's pixels, maybe it's a line, it becomes a line, a shape, it becomes a shape I know about, and the output may be a cup. Or let's be honest, it's more likely to be a cat in most cases, but let's just say it could be a cup here. And this is actually a very similar structure. It's the same thing. Instead of pixels as input, it could be speech. So you start by, this is sound, this is acoustic information. It starts to become sounds I know about for a specific language, and then hypotheses about, this is a word, this is a sentence. Out comes, in the output layer, a sentence. And let's see. Yeah, so one thing to call out here, you can see it takes decisions. At each node, it takes a decision. It may have several hypotheses active, but at some point it starts to cut off hypotheses, and it continues and ends up with what may or may not be the correct answer, but potentially multiple answers. Typically, most often, the wrong answer is discarded along the way. And so let's do a test to illustrate specifically this decision-making process. So I'd like you to, all of you here, to participate in this right now. So I'm going to show you, here's a colored dot. So I'm going to show you another colored dot like this. And when you know the answer, just shout it out, point at it, let me know one way or another that you have found it. I'll give you a clue. It's very easy, and it is not a trick question. Okay? Ready? Find another dot like this. Let me know where it is. All right? Good. Excellent. Let's try again. That was easy. Okay. Okay. All right, so what happened? Something happened, right? You got a very easy test, and then you got, okay, there was a bit of a trick question there. You got a really complex, or significantly more complex test. And so a few things happened there. For one thing, the latency to get a response got significantly increased. It took a lot longer for you to get to a decision, to an answer. The processing that happened in your head was significantly more as well. You got multiple hypotheses. It wasn't enough, you weren't clear in the specific answer, you had multiple at a lower confidence rate. And so this is, of course, just to illustrate that as it walks through the possible different paths, and as it starts to discard hypotheses, keep several active, it may discard the right one. And it may be unclear exactly what makes it take a certain path. And we'll take a look at that in just a little later here. But you can see why sometimes it'll struggle, and it'll struggle to find the right solution, the right answer, even sometimes when it's something that feels very easy to us. And so, nonetheless, it gets it right most of the time. And again, back to these three: data, cloud computing, algorithms, is sort of what has gotten us to this. And so, I realize this is getting a little philosophical, but as we're sort of simulating how AI models work, which in turn is simulating human behavior, but I hope this sort of helped to illustrate what's happening, what's going on under the hood. And of course, no surprise, the generative AI models, which is now sort of getting most attention, ruling most of the implementation around AI, are doing some really, really incredible capabilities. GPT, the type of model, generative, pre-trained, transformer models. This is the new breed of models, and they are really significantly larger than the earlier versions. The generative part, of course, here is just, it can generate new content, new text, images as well, audio as well. We'll get back to pre-trained. Transformers, the type of architecture that's been used for a while, but has been used on this type of model very, very successfully. The pre-trained part is really interesting. So that means that it's been trained on significant amounts of data, and it's capable of doing a vast array of tasks and activities without being adapted specifically for the task. And so that's why we start to talk about these as foundation models. They're very capable at many different things. You can then adapt them through different means to specific tasks, but at the foundation, as they're built out of the box, they're capable of many, many different things. And let's see. So their ability to understand the user input, for example, a question, a query, and then generate responses based on that input, it feels very, very convincingly human, or at least it can. So I've worked a little over 20 years in AI. I can honestly say that this is different. This is very different. We now see both broad and deep impact with many, many more people trying out AI, asking about AI, using AI, and having questions and concerns about AI. And so I want to introduce you to this guy before we go further. So the elephant in the room. Yes, there are potential for very positive impact. We've seen many, many examples where AI can have life-altering positive outcomes. But there are risks. And so it really is important that everybody using AI, particularly those building solutions, building technologies that leverage AI, that they have an understanding of what those risks are and how you can integrate mitigation strategies to counter those as much as possible. So with big changes, particularly big changes with a lot of unknowns, it's only natural that there are concerns, doubts, even fear. And so it's important to understand that those that have these sort of reactions, that is very well founded, and then sort of really understand where that's coming from. There may be concerns around, for example, data security, data privacy. How is the data used to train the models? How is the data used when you're interacting with the models? Very valid questions, important to really go deep on that. Job displacement, is this going to take my job? In most cases, definitely not. Some cases, yes, but in most cases, it's going to change your job. It means that you need to be able to use new technologies because it's going to automate some of the tasks that you have on a day-to-day basis. And the fact that it can be confidently inaccurate. You've heard hallucinations, that it can generate content that looks very real but is absolutely incorrect, is a problem. There are ways to get around that, there are ways to sort of reduce that, but it's also can be a source of misinformation, not necessarily disinformation. It can be misinformation that sort of is generated for people who read some content, not knowing that it was generated. They may sort of just run with that information. So it's important to, when you have generated content, that you understand what the potential negative consequences of that could be. And so when we look at the use of AI and modern technologies, obviously it carries a lot of inherent risks alongside with its enormous potential. So we have worked for a while now, way before these new models came out, on putting together a responsible AI principles. And so sort of take a step back, stop, think about the use cases, think about the big picture in which AI solution is built. And so we came out with these like 6-7 years ago or so, and have built these now into not just design principles, though that's what they were sort of grounded as, but also converted these into engineering principles. Anybody at Microsoft who builds AI, who trains models, who integrates AI capabilities into the product or service have to go through responsible AI training. You have to do compliance review to make sure that you're actually allowed to ship this capability. And so having turned these design principles and philosophies into tangible, executable engineering processes is absolutely critical. We have information here available for everyone to use. We use these principles internally. We encourage their use externally. Other big tech companies have similar kind of principles. Some of these help in the discussion around regulation. Regulation, as we talked about yesterday, is moving by design very slowly. AI is moving very fast. So the self-regulation is not a long-term solution, but it is needed until the actual regulation is in place. So to this, of course, understanding how AI makes mistakes, and just acknowledging the fact that it does make mistakes. In fact, it's been making mistakes for a while. AI has been around for quite a while, obviously gotten more and more accurate, but it's been constant that there are mistakes. The difference now is that those mistakes, they look very real. And that, of course, is a challenge to the consequences, or downstream consequences of this. Because it will always make mistakes. It'll never not make mistakes. And so actually I wanted to show an example. We'll see if this works. It was working before. All right. 1 second. All right, we'll give it a question. Is an anaconda, is this too small? Can you see this? Too big to fit in a shopping mall. All right, let's see what happens. Apparently not a lot. Oh, it probably got out of, here we go. I am connected. Ah, interesting. Let me try that again. All right, silly question, obvious answer. See, interesting. All right, let me show just the other, because I did this like an hour ago. And this is what I got. Is an anaconda too big to fit inside a shopping mall? Yes, it is. No, it's not. It's so it's clear that there's a good reason. I think I'm hypothesizing here. I think there's a good reason for why it's come up with this. We'll talk about that in just a second. But the main point here is the capabilities can be so impressive that it can be easy to sort of forget that it's dumb underneath and just sort of hand over decisions because it feels very capable. It knows things I would never know about. So clearly it's very intelligent. But it does also make very dumb mistakes, and that can have very real consequences downstream, particularly if you work, for example, with at-risk populations. People who are refugees, who are fleeing conflict, anything sort of that can go wrong, you need to understand how and why it goes wrong. And so let's take a look here. I did have it as a backup here just in case. So why does it do this? So is the model not able to see that anaconda is clearly smaller than a shopping mall. It fits. You see here, own local hero here, Steve Irvin, apparently putting an anaconda around a surprisingly calm Jay Leno here, and a regular, at least sort of American-sized shopping mall. Clearly, it fits in there. So I think that's not the issue, that it doesn't understand that when you look at the size of an anaconda, which is big, and compare it to a shopping mall, obviously it doesn't fit there. I think the issue is that it got distracted. It has some information about, and again, I'm just guessing, that all the data it has gotten around anaconda, all the data has been trained on, all the context, the embeddings in which anaconda exist, is about it being big. One thing that's really characteristic around an anaconda is that it's big. And so almost any question where you would ask, is an anaconda too big for X? It's generally yes. So I think if we go back to the how it makes decisions, I think it just took the wrong path here. The right path, maybe it was sort of a second choice. And actually you saw the one I did just now, which is an hour later from the previous one, it got it sort of right. It added information about, well, maybe it fits, but it shouldn't be there. The more important part is that there are human beings in there, so it's a dangerous animal. It doesn't really matter whether it fits or not, it shouldn't be there. And so just to make the point that you need to understand the type of mistakes and how that can show up. And so I think it's important to make a distinction between, or it's worthwhile to make a distinction between mistakes and misuse. Misuse can be intentional, it can be unintentional, it can be unexpected consequences. Though the scale of the potential negative consequences may be the same, but the mitigation strategies are different. And so we should talk a little about mitigation strategies here. There's been some good coverage of some of these already in some of the other talks, yesterday and today in particular. I want to call out prompt engineering. I won't go too deeply in there, but prompt engineering and grounding. Prompt engineer is a new job title that did not exist a year ago. It is something, I'm sure you've been exposed to this, but it's a very, very important skill. It's a very valuable skill to have to really understand how you can get the most out of the models. I like to see it as, for example, how you would interact with an intern. So be very specific about what you want. A highly intelligent intern who has access to all the information, but who does not know intuitively what you want. So if you want to give a task to an intern, give that intern very specific instructions about what you want, how you want it, et cetera, et cetera. So the more specific you can be in how you tell the model what you want, the better. You can ask it, for example, not to make stuff up. If you don't know the answer, just say you don't know. And that means that if the confidence is below a certain threshold, it'll just say, okay, I don't know. You can restrict the sources. You can tell it to only look for the data, only look for the answer in this data I'm pointing you to. If it's not there, then say you didn't find it. Again, you can point it to specific data, your own resources. You can ask it to do chain of reasoning, which helps both you and it get to better results. So instead of asking it, for example, how many lamps are in the city of Sydney, it may just give you a number. But if you ask it to how many lamps are in Sydney and tell me how you got there, it'll go through the individual pieces of information that it got it to there. And as it turns out, it actually gets better results. It's more accurate when you ask it to do that. And it builds confidence on your side sort of in taking that information and understanding it and sort of believing it, feel more reliable. Along with the OpenAI capabilities in Azure, we have a few tools that can help you. There's a content safety tool that can detect and trigger if the user input contains offensive content across these 4 different pillars or categories: violence, self-harm, sexual, and hate. As well as if the model generates a response that has offensive content, it'll trigger and stop that from happening as well. You can change this, though there's a default, and there's an exceptions process for you to be allowed to actually change it, because it's in there for good reason. Some of the people we're working with, some of the nonprofits, they just sort of naturally work with a lot of potentially offensive content. For example, nonprofits that work with human trafficking or work with people in conflict zones, there may be vocabulary, there may be terminology in the texts that they're working with that will trigger this all the time. So you can apply for an exception. There's an ethics board that will review, and if there's a good reason, you can get that exception. The Responsible AI dashboard is another really good tool where you can look at your models. If you have trained your own models, you have adapted your model, you can sort of see how it's performing, how it's what's working, what kind of errors it's seeing in its real life deployment. You can do checks. For example, you can do like a fairness assessment to make sure that the model is not favoring certain demographics over others. Fine-tuning. Most people, some people are very excited about, interested in sort of training their own models. The large majority of users and use cases and organizations do not need to do that. The models are very, very capable out of the box. If you want it to be optimized for your scenario, for your data fine-tuning, along with prompt engineering, in most cases will get you there. And then, of course, on the user experience side, that's where you can implement some decisions around how you inform the users about, hey, this is generated content. In case there are any errors in there, any inaccuracies, then that would be why. And then responsible AI training. It's one of the first things we do when we work with these humanitarian organizations is have a full session. Sometimes it's a full day where we walk through the details of the responsible AI principles, of the engineering implementation practices, some of the other tools that are available to them. You can see the link there if you want more information about responsible AI. There's a ton of resources, documentation, templates, assessments, and some other tools as well. And along with that, having a human in the loop, that sort of made me more on the UX side. If what is generated has, depending on sort of what happens with it downstream, if it is something that gets consumed where inaccurate information can be devastating, well, definitely have a human in the loop. If it's more sort of a social interaction or summarizing documents or so, the cost of having inaccurate generated content is less. But you understand your use case. Think about how inaccurate generated content can have a negative impact on downstream users. I alluded a little bit to the content safety. There's a review process. Some of the other services, most of the services we have around AI in Azure, you can just go right ahead and use them, sign up, and you start using them. Some of those you actually have to ask for approval. And that is a very direct outcome of some of our responsible AI principles and sort of ethical discussions. So for example, voice cloning, you can clone your own voice, so you can generate synthetic speech that sounds exactly like you. And you can now do that with very little audio. But because of the potential for misuse, impersonating someone else, you have to apply for access to that service. The voice talent you're using actually has to say, my name is blah, 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 and I'm okay with my voice being used for this, so that you can't just sort of use it on someone random and then start to make recordings of that person. There are a few other services that have the same process. You have to apply for approval. It goes to ethics review of the specific use case. Facial recognition is another one because of its potential for misuse. For example, in surveillance, in areas where there is significant risk of misuse of surveillance, and again, particularly around at-risk populations, that is a key concern. So there have been pockets in the tech sector that have lived by sort of this tenet of run fast and break things. I will say it does have its merit. It has gotten as far in some areas, disruptive technology and all. However, when you're working with technology that has disruptive potential at a societal scale, running fast and breaking things just will not do. It's just not an option. The stakes are too high, and not just for humanitarian use cases. And so it is important to really understand how the technology works, how it makes decisions, and how it makes mistakes, and then understanding what you can do to sort of, in your design or in your usage or in your information sharing, accommodate for that and implement mitigation strategies. So the goal is not to eradicate the risks of mistakes. The goal is to significantly reduce the risk. We saw some of the mitigation strategies. Prompt engineering will get you very far. And then to have mitigation strategies in place for when it does make mistakes. And so if you know which kind of mistake it makes, you can understand why it makes them, and you can more easily anticipate them and implement these strategies. And so with the maturity of the technology, of the underlying technology, we've seen very powerful, very mature, very capable technologies. I honestly believe that the biggest factor, the key limitation is imagination. It's understanding what the technology can do, it's understanding its value, its potential, its opportunities, and its limitations, and how you use it. It's connecting the dot between what the technology can do and how it can impact your specific use cases and challenges and opportunities. And that's sort of really where it all comes together. And so I hope this has helped you sort of get a sense of what the technology can do, some real world examples, and how it makes those decisions and mistakes, and what you can do to counter them. So that is all I have. And I think we have a few minutes for questions, in case there are any. So thank you. Any questions? We have a microphone. I know I stand between you and likely drinks, so appreciate we're running towards the end here.
You were talking about some of the tools from Microsoft have an approval process.
Yes.
Can you talk about where those approval processes come from? Who's making them? Who's deciding what needs this approval? How does all that work?
Yeah, good question. So as I mentioned, the large majority of the AI services on Azure, you just sign up, you start using them. Because of the potential for misuse and negative impact, if you don't understand sort of what you're dealing with, through the we have the Office of Responsible AI. We have an entire team dedicated specifically to that. In addition to that, we have, it's called the Ether Committee. It's an ethic review committee that takes up some of the really big, hairy questions about, should this be a thing that we allow to be used in a service for sort of broad consumption. And so which specific services have to go through the gating process, the approval process, is a decision that comes from there through understanding not just the good it can do, but focusing specifically on how can this be misused. It's clear that even some of the out-of-the-box generative capabilities of these large language models can be misused for a number of different ways. But some of the services, some of the capabilities are just sort of inherently risky. And so therefore, it's important to be able to state your use case, and that goes through an ethics review. And in most cases, it gets approved. I have seen not many examples where it was rejected, but it does happen. All right. Any other questions? You're all ready for wrap up? Okay. All right. Well, thank you, everyone. Thank you for joining today, and enjoy the rest of the day.